Okay. Can I stay here? No? Hello everyone, my name is David Santos. I'm an NSX engineer based in Brazil, and today we're going to talk about NSX T and what we can do about security. So, the benefit of NSX T is that we can enforce security without changing topology. We can enforce security on VMs, we can enforce security on pods in a Kubernetes cluster, and even in bare metal service. So if you need to enforce a policy, we do this in the closest communication within the application, whether a VM or a cluster, a Kubernetes cluster. This is delivered by the distributed firewall that we can deliver the features on-prem and also in the cloud. Today, we can deliver that on AWS and Azure using agents installed in the VMs. And probably next week, we're gonna do that using the native security groups that are available in Azure and AWS. We're gonna have the option to choose either using an agent or using the native security groups. So, how does it work? It's pretty simple. We create a group that can be made of VMs, containers, labels, and networks. And basically, the group includes and excludes objects in the dynamic way. For example, we're going to create a group called Web that will have all the VMs with the security tag, the tag Web and scope security. So here's the NSX T UI. We have two VMs here, Web 1 and Web 3. We're going to apply the tag in the first VM. Then we're going to do the same for the second VM. And after that, we're going to create a policy of membership, a membership criteria. We're going to create a group and associate the membership criteria of this group with the tag. We can choose here either a VM, a logical port, which is a container, or a network, or anything. After that, we can see that our VMs are inside this group, and you can use that in our distributed firewall. The next demo, we'll talk about how the distributed firewall works. So here we have two VMs with the tags, and our group is already created. We're gonna create a rule that will block all the communication between VMs, allow external access HTTP, and block anything else. That's a pretty basic rule. So here we are in the Web 1. We are in the subnet 131 with 11.11 is my IP, and I'm going to create a policy that will block the communication between those VMs. So I'm going to reject everything. And the destination will be my security group. And I'll change here from allow to reject. I can also use drop if I want. At this moment, all the traffic will be rejected, either the pings or the communication, the outside communication. We're gonna tune this rule now. We're gonna add two more rules. One, blocking all the communication between security group to security group. It's really nice that we have a drag and drop here. And it's really easy to manage the rules. And the second rule, we're going to allow the external traffic HTTP. My communication between VMs is still dropping, but I can access the VMs now from external access. and if I try to do a SSH, it will drop too. Nice. And about Kubernetes, how does it work? So Kubernetes integrates natively with NSX. Basically, Kubernetes will deploy the pods, and NSX T will deliver the network components, such as firewall, layer 2 networks, layer 3 networks, like the full gator for these networks, NAT rules and routing rules when they are needed, and also the load balancing. So the tags are also native. So you deliver routing switching, SLB, distributed FIDO, and visibility. In this demo, we're gonna deploy a Kubernetes. We're gonna deploy a namespace, and on top of that, application. So I'm gonna create a namespace in Kubernetes, and for each namespace that's created in Kubernetes, you will deploy a tier 1 gateway, that is a router, and also a layer 2 switch, an overlay switch. After that, we're gonna log in the namespace that we just created, and we're gonna create our application. I have the application here within, with and without the labels. So here's the application without the labels, and now the same application with the labels that we are gonna use to deploy the micro-segmentation. So with this single line, we can choose which group that pod will belong to. Here I can see that my pods are being created, and I can check those in NSX too. We can see that they are attached to the logical switch already. All the pods that we just created, and also they are part of the security group that we have configured here. Now we're going to create a service and ingress to load balance these containers, and all the components needed to this load balance will be done in NSX too. We're going to create a port on service on port 80. And with those labels, they are they will load balance, the ingress will load balance to the containers. We can check here in the load balance that our pods are already in the pool for load balancing, and we can check the application that's working. If I refresh the website, I can see the load balance among the pods. And this application has a port scan inside the pods. So I start a port scan, and we can see that port 80 is available. Now we are gonna enable the rule that will reject the traffic between the pods, and we will run the test again, and you can see that we deploy micro-segmentation between containers. That's really nice. And the application is still running. And the last part, we're gonna deliver the security on cloud native workloads in Amazon and Azure. For this, we need to deploy, in addition to the NSX Manager, a component called Cloud Services Manager, Cloud Service Gateway, which is the component that talks to AWS and Azure. Besides this component, we also need to deploy a cloud service gateway on each of those public clouds. The first step after deploying the cloud service manager, integrate that with the credentials of the cloud. We're gonna deploy here the NSX Cloud Gateway. It's pretty straightforward deployment. We choose the certification file. And then the network configuration, the availability zone where we're gonna deploy that. After a few minutes, it will deploy. It takes around 5 to 7 minutes, depends. And here you can see that's already a managed VM on the cloud. After the deployment of this component, we need to install the agents on the VMs. So we're going to install the agents in the VMs. In the new version, it's not needed anymore. If you want to use the cloud native security groups, you can. Actually, you have the option to choose. And now we're going to create the tags on the cloud portal, actually in my AWS console. I create the tags in the cloud, and I'm going to consume these tags on-prem. So I can see here that my tag is already on NSX T UI, and I'm going to use this tag to create a security group. Now I'm the security group. 1 minute? Okay. I create a security group, create a membership criteria using the virtual machine, tag 2019, tag VMworld, scope 2019. And here I need to include this and I need to include two parameters to identify that tag is from AWS or Azure. After that, I create a rule using that security group that I just created. I'm gonna do some tests here, try to ping my application, it will work. I will publish the rule, then at the same time, it will drop the traffic. And also, if I try to access the application, it will not be available. Then I'm gonna disable this rule that I just created, and I can see that the application comes back and also the pings. So that's all that I have for you guys. Thank you very much. I hope that you enjoyed that.